Most of the repairs finished. Took time to stock up. What's going on?
Stella, we're having another argument here. All Ben eats are burgers.
I mean, it's no good for them, is it? Just junk food, aren't they?
Yeah. If all you eat are burgers, you're just going to be made out of burgers. Made out of junk.
I'm made out of exactly the same stuff as you. It's got nothing to do with what I eat. And anyway, they taste good.
Stella, what do you think?
Food for thought. He didn't look like he was made out of burgers. What are human beings made out of? Well, a massive 95% of me is water, about this much. Quite a lot of carbon, enough salt to fill 6 salt cellars, enough fat to make 7 bars of soap, and enough iron to make small nail. The stuff our bodies are made out of has to come from the food we eat. I've sent Femi to find out more.
OK, so we've all got to eat. But what if you're at sea? You only get to eat what you've remembered to bring. That's true of the people I've come to meet. They're about to start off on a yacht race around the world, and I have brought them some supplies.
But on board EF Language, Pia's not impressed.
These bags are too heavy. We have to keep the weight down. A heavy boat and supply might lose us the race.
The crew are certainly going to need to eat healthily, and they've had to think carefully about the food they're taking on the trip.
The nutrients our body need could be put into groups. Carbohydrates, proteins, fats, and of course vitamins and minerals. And we made sure that we have what we need of each. Carbohydrates provide readily available energy, and we need a lot of carbohydrates. We use up a lot of energy sailing, so we have to eat twice as much as we do on shore.
But the trouble is, the food rich in carbohydrates that I've brought the crew are either too heavy, too bulky, or would go stale. Almost all the crew's food is freeze-dried, from fruit and yoghurt to their omelettes, and even this stroganoff. The meat in this provides a source for another nutrient, protein, which is vital for our cells to grow and to help build new cells. The crew are going to be sailing close to the Antarctic, and there the cold will mean they'll be relying on their body fat to keep warm. Fats are found in foods like biscuits and butter. Fats are a good source of energy, releasing energy more slowly than carbohydrates. I had a go at cooking up some of their freeze-dried food to see what it tastes like.
Smells good. Well,
It's not bad. Can you get everything you need for a healthy diet from this freeze-dried food?
not quite. We need a lot of different vitamins and minerals. They do different jobs in the body. They're usually in a balanced diet, but when food is freeze-dried, it's destroyed.
Fresh fruit and vegetables are the best source of vitamins and minerals, but what I've brought would perish and is still too heavy.
So we have to have all our vitamins in a tablet form like this.
I'd rather eat fresh food any day.
But we're prepared to do this to win the race.
Better get a balanced larder together for my submarine. Not a lifetime of food, but plenty carbohydrates, proteins, fats, vitamins and minerals.
Carbohydrates are easy to identify. They make up nearly all of bread and pasta, for instance. But it's not so easy to know if the food you're eating contains some of the minerals and vitamins you need. Let's experiment. Using this magnet, we can see whether my breakfast cereal contains any iron. Any iron in the cereal will be attracted to the magnet. Look, a bowlful of my cereal contains this much iron. All packed up well to fit inside my sub. Not much space in here.
The knack of packing things into a small space is used inside the human body. This box is about the same length as my body from mouth to anus. But inside, one big tube about 10 meters long. Packed inside us is the same length tube, and it's called our alimentary canal, and it runs right through our bodies from mouth to anus.
Wow, a 10-metre tube inside me.
But if it's one big tube, why doesn't food just fall out the other end?
Well, it does. It goes down the toilet.
It doesn't fall out, does it?
No. And it doesn't all go down the toilet, does it, Stella?
Only the bits of food our body can't use end up down the toilet. The useful bits of food are digested and then absorbed into the body on the way down.
Exactly how that happened is Femi's next investigation.
It's getting cold, and I'm no nearer even starting this investigation. Well, there's no point wasting it, is there?
Now then, she might not realise it, but her investigations have just started. She's taking the first steps in breaking down of her food. The mouth is like a chopping board. Well, it is. The teeth chop up the food and grind it to a pulp. It's a very physical process. Chewing also increases the surface area of the food, which helps the first chemical processes of digestion. And that's where saliva comes in. Wonderful stuff, saliva. All 1.5 litres a day of it. It moistens the food, making it easier to swallow. Food's got to be broken down chemically so that the large molecules of food can be changed into molecules small enough to be absorbed by the body. Saliva contains an enzyme which starts breaking down the starch in the bread and chips into sugars the body can actually use.
OK, so what's happening here? In the mouth, the carbohydrates start being broken down, but I don't think my body's actually absorbing anything yet.
She's right. There's still more breaking down, more digesting to do. Once the food reaches the stomach, glands in the stomach lining secretes a liquid called the gastric juice, which helps break down protein. Everything's mixed together and churned up by the muscles in the stomach wall. A lot of the carbohydrates and some of the protein have been broken down, but hardly any of the fat from the food's being digested yet.
I'm stuffed. Couldn't eat another thing. Oh.
So, now the food's in my stomach, the proteins and carbohydrates are breaking down. But what's next?
Hi, Rusty. I thought I'd come and see what you're up to.
Well, I thought I'd have a look and see what happens to the food after the customers had it.
Well, I think I've got a pretty good idea what happens to the food up to when it gets to the stomach. In fact, I can feel it there right now. But I'm not too sure what happens after that.
Well, it all moves on to the small intestines.
Ah, the duodenum. What happens there?
This is where the fats in the burger are broken down. Bile, which is made in the liver, together with enzyme, this time from the pancreas, break down the fats. These enzymes from the pancreas complete the digestion of the rest of the carbohydrates and the proteins too.
So, in the duodenum, fats are dispersed into tiny droplets. And carbohydrates and proteins are digested here too.
So now my burgers and chips have been well and truly broken down by all the enzymes and everything. But is my body actually able to make use of all the nutrients from the food yet?
Just about. That's what happens next in the next part of your small intestines, the ileum. Help me fold these, Femi. All the nutrients from your digested foods passes through the walls of the ileum to get into your bloodstream. This means at last the body can actually make use of the nutrients.
Why am I folding up these cloths, Rusty?
The walls of the intestines aren't flat. It's covered with millions of tiny little fingers called the villi. There are about 4,000 villi in the area of the size of a fingernail, and each of these contain blood vessels which absorb the nutrients from the body.
So, because there are so many, there's a much larger surface area to absorb all the nutrients.
She's right. By the end of the small intestines, nearly all the nutrients from the food have been absorbed into the blood system.
So, by the time the foods pass through the ileum, they're broken down enough for the nutrients to be absorbed into the blood.
And it's on to the last stage of digestion.
The large intestine. But what's actually left by now?
All that's left is a little water and undigested food. Fibre, for instance, which helps to keep the feces moist. So there's not much of Femi's burger left. A little bit of water which has been absorbed through the walls of the large intestines. The remaining material, the feces, becomes a little bit more solid. And that passes out of the body through the anus.
So food is broken down or digested in two basic ways, mechanically and chemically. Let's look a little more closely at the chemical breakdown of food by enzymes.
Take the carbohydrate starch, for instance, found in bread or potatoes. Starch is made out of many, many starch molecules. The structure of starch molecules is a long, complex chain like this.
Our bodies just can't absorb a large molecule like this. And that's where enzymes come in. They encourage a chemical reaction which breaks down the complex molecule into smaller molecules like glucose, a simple sugar which is soluble and easily absorbed in the blood. You can taste this happening when you chew bread for a long time. Eventually, it tastes sweet, as your saliva has broken down the starch into more simple sugars.
Fats, in butter and oil, for example, are broken up in a different way. This beaker contains olive oil. Add a solution of washing up liquid and water, and watch the oil break up into little globules. In your body, the bile helps the fats to break down like this, which gives them a much larger surface area. This large surface area helps enzymes from the pancreas to digest the fats. Once the food's been digested into small enough molecules, it can pass through the gut wall into the bloodstream and be used by the body to keep us alive.
I've got a good idea what food I need to survive. But what about Boffin here? What does she need? Maybe Femi can help.
Now, this is what I call an investigation. Out in the wild, observing the feeding habits of wild animals. My every sense geared to stop it from becoming somebody else's dinner. Well, actually, I spent the day here at Whipsnade Wild Animal Park, finding out what you can tell about an animal from its diet. Let's see how much I've learnt.
This week on Blind Diet, we've got 3 great animals. Well, welcome to the show, Femi.
Thank you.
What you've got to do is guess what animals are lurking behind the screen, but all you've got to go on is what they've had for dinner. So first, number 1.
This is a day's food here. Well, it's certainly a plant eater, a herbivore. And because it eats grass or hay, which has a very low nutritional value, it
I guess it spends a lot of its time just eating. This is a huge amount of food for just one day, which means it's a big herbivore. No, they don't eat fruit, do they? I think it's a large deer or antelope.
Well, let's go behind the screen and see if you're right.
Whoa! Hello, you've been very quiet back here, haven't you? Now, Peter, how can an animal this size get all the nutrients it needs from just grass and a bit of fruit and veg?
Well, one thing, Femi, is that they do eat very large quantities of food. But what's really interesting is that they get lots of minerals and salts by eating earth. So what about number 2? Now, what do you make of this animal, Femi?
A meat eater. We have a carnivore behind the screen. Oh, well, meat is an excellent source of nutrients, so this animal doesn't have to spend all its time eating.
But bears are omnivores. They don't just eat meat, they also eat grass and fruit.
On the other hand, it could be an energetic meat eater. It's not a big cat like a tiger or a cheetah, is it?
That's exactly right. Come and have a look.
Cheetah. Well, I'm pleased there's a fence.
But in the wild, Femi, cheetahs can starve to death. They use so much energy catching their food, they've got none left to stop other animals, like lions, from stealing it. And finally, Femi, number 3. Small birds. But, Femi, number 3 only eats about once every 10 days or so.
Ah, now, if it eats that infrequently, it can't use that much energy.
So it's not going to move around much. But a crocodile would need to eat more than that. Maybe it's a snake.
I was right. Meat barrel.
Boa constrictors are extremely efficient eaters. Their bodies can digest nearly everything they eat, including the animal's bones.
Nearly all stowed away. But before I go, think about this one. The intestines are a good example of how you can make a large surface area out of a small volume. Well, how can you make the beans in this jar have the largest possible surface area?
Well, if you put them in a large round jar, that would spread them out, giving them a larger surface area.
Yeah, but there would still be loads of beans in the middle of the jar.
Well, if the intestines have such a large surface area, what about trying to find a jar that's more like the intestines?
Yeah, a tall, thin jar. That would make the beans have a large surface area.
Maybe the answer is just to take the beans out of the jar altogether and spread them out on the table.
What's going on?
Stella, we're having another argument here. All Ben eats are burgers.
I mean, it's no good for them, is it? Just junk food, aren't they?
Yeah. If all you eat are burgers, you're just going to be made out of burgers. Made out of junk.
I'm made out of exactly the same stuff as you. It's got nothing to do with what I eat. And anyway, they taste good.
Stella, what do you think?
Food for thought. He didn't look like he was made out of burgers. What are human?
The nutrients our body need could be put into groups. Carbohydrates, proteins, fats, and of course vitamins and minerals. And we made sure that we have what we need of each. Carbohydrates provide readily available energy, and we need a lot of carbohydrates. We use up a lot of energy sailing, so we have to eat twice as much as we do on shore.
But the trouble is, the food rich in carbohydrates that I've brought the crew are either too heavy, too bulky, or would go stale.
human beings made out of? Well, a massive 95% of me is water, about this much. Quite a lot of carbon, enough salt to fill 6 salt cellars, enough fat to make 7 bars of soap, and enough iron to make a small nail. The stuff our bodies are made out of has to come from the food we eat. I've sent Femi to find out more.
OK, so we've all got to eat. But what if you're at sea? You only get to eat what you've remembered to bring. That's true of the people I've come to meet. They're about to start off on a yacht race around the world, and I have brought them some supplies.
But on board EF Language, Pia's not impressed.
These bags are too heavy. We have to keep the weight down. A heavy boat and supply might lose us the race.
The crew are certainly going to need to eat healthily, and they've had to think carefully about the food they're taking on the trip.
Most of the repairs finished. Time to stock up.